Welcome students to your favorite channel Producer Classes as BSc, and today we are going to start with a new concept that is a part of moment of force, that is when a body is said to be in static or kinematic, that is dynamic equilibrium. So students, let's start with the new concepts, and obviously that particular method, pen and paper, pen and copy method. And but I 99.99% sure that that particular uh, lecture marks on your heart. So please students, see till end that particular one. Okay. So let's try, and if you think that this is the best concept and this is the best well-known technique, then please subscribe. Okay, thank you. So students, for today's class, basically I teach you the remaining part of the previous for that particular chapter, and the equilibrium of bodies, and those who are join in that particular class, so go back to the previous lectures, that is up to 5 for the only that is IIT foundation course for ICSE-10, and it is IIT foundation. So what is or when a body is said to be in equilibrium? So for that particular concepts, students, first of all you have to clear your concept about inertia, So we know that the inertia, that is mainly two types, that is rest of inertia and motion of inertia, and there are another inertia, that is direction of inertia, So what is rest? That particular body is at rest, and with respect to some reference frame, and if we take myself as a reference frame, then we see that that particular pen is at rest and that particular pen is in motion, and if we rotate that particular pen, then it try to rotates in a particular direction, that is clockwise direction, but the retarding force acts, that is frictional force, and can try that particular body to be in rest or resist that particular inertia, that is direction of inertia. So what is rest? A body is said to be rest when that particular body doesn't change its position with respect to some reference frame, that is, a body is in rest, it maybe seems that it is in motion with other frame. If your friend suppose in a platform, then you see that the train is moving, but when a particular compartment, within a particular compartment, within that particular compartment, the peoples that are the passengers, they are waiting for the next station. They see that every passengers within that particular compartment is at rest. So rest and motion are two relative concepts. There is rest, there is motion, there is direction of inertia when you turns within a particular rotary, and if you suddenly want to change your position, then that particular inertia concept comes into play. that is direction of inertia. That is direction of inertia. So students, we are basically deals with equilibrium. So first of all, this is the concept number 1. Concept, this is concept 1. And concept that particular, all the concepts are required for explaining what is equilibrium. Next, concept 2. Concept 2, that is acceleration or retardation. What is acceleration? What is retardation? And it is a very simple example. Suppose this is pen is here, and if we that is the pen is here, but if that particular pen is in motion, that is free fall, then its velocity increases. Why its velocity increases? Due to, then we say that due to gravity. So acceleration due to gravity, when acts on that particular body, gravity force acts on that particular pen, then it is accelerated. But if we giving a particular force in that particular pen, and the pen suddenly stops, or it stops after some distance it covered, so this is called retardation, that is the velocity decreases. So students, there are some facts where its velocity increases, that is called acceleration, or its velocity decreases, that called retardation. So when acceleration or retardation acts, or acceleration or retardation, we can say that the body is in accelerated motion or in retardation, then we must say that is F equals to ma. We'll all know that. What is F equals to ma? That is, this is the force, this is the mass of the body, there is pain here, and this is acceleration. So F is a vector quantity and acceleration is also a vector quantity, that is, it have a specific direction. If we applied a force along this direction, that is, there is the pain, and I applied a force along that particular direction, then the acceleration takes place along that particular direction. So force equal to ma, acceleration takes place along the applied force, direction of the applied force. So acceleration or retardation comes into play, or we can say that the body is in accelerated or retarded, then something force acts on that particular body. So force and acceleration are, we can say that this is directly proportional if mass remains constant. Concept number 1, you have to know what is rest, what is motion, what is direction of inertia. Second concept, acceleration, what is retardation. That is somehow a motion related with a particular body. Motion is related with a particular body. Students, let's see the definition. What is equilibrium? When a number of forces acting on a body produces no change in its state of rest. When a number of forces, suppose this is an object, and when a number of forces acting on a body, so if we applied a force along this direction, then at the immediate retarding force, that is frictional force, that is frictional force. Frictional force, and this is applied force. This is applied force. So when we apply a particular force on that particular body, then frictional force comes into play along the tangent. What is tangent? Suppose this is a surface, that is rough surface, and a body is kept along that particular surface. So there is a building blocks. So there is a locked at that particular position, because at that particular position the surface area is small. That's why pressure is greater, since pressure equal to force by area. So at that particular position, the area, surface area, the contact area is small. That's why the pressure at that particular nib is greater than particular ones. Why? Because the surface area is small at that particular position. So that's why pressure is greater. That is when at that particular point it is locked, and if we breaking the lock with the application of some force, then in opposite direction a frictional force comes into play. So when a number of force acting on that particular body, when a number of force, there are two numbers. The number of force here act is the applied force as well as the frictional force. So the definition is when a number of forces acting on a body produce no change in its state of rest, but the applied force doesn't change it. And suppose you trying to shift your almirah from a place to another, but you don't do that. It may be due to its weight is act along this direction, and this weight is more, and normal reaction acts, and that's why the frictional force is greater, because always frictional force depends upon that weight. Normal reaction actually. So due to the weight or due to the normal reaction, the frictional force is greater. That's why you are not able to move that particular almirah to a particular position to another position. So, and if we explain and that particular body, how many force acts? There is mg acts along downward direction. Due to this, that particular surfaces gives an outward normal force, and you applied a force along here to move that particular body, and a frictional force comes into play. So P is the applied force, that is frictional force, that is normal reaction, and that is weight. So this is weight, this is weight, this is applied force, APPLID, applied force, and this is normal reaction, and this is frictional force. Due to this frictional force, we are able to move, able to walk. And when it is slippery means there is less amount of frictional force at that particular place. So applied force, normal reaction, weight, and frictional for all the forces acting on that particular almirah, and you are not able to move it. That means when a number of forces acting on a body produce no change in its state of rest. Suppose this is the almirah, and you are you trying to move it. So that's one. This is mg, this is a normal reaction, and you applied a force along that direction, and along that direction there is a frictional force. And your mom, suppose, standing here, see that particular action, your action, that's my son is trying to shift something from that particular place to that one, but she or he is not able to move it. So if we consider this is a reference frame, this is the reference frame, that is your mom is a reference frame. What is reference frame? And we learn it in the something motion in chapter motion. And so just think that it is a coordinate system or system that with respect to this one it is in motion or not, this is in rest. So this for that particular reference frame, and your mom sees that this is in rest. So when a number of forces, when a different number of forces acts on that particular body, and when a number of forces acting on a body produces no change in its state of rest or motion, the body is said to be in equilibrium. So now we can say that this is in equilibrium. So this type of equilibrium is called what is this? Static equilibrium. Static equilibrium. So what is the static equilibrium? When a body remains in the state of rest, when a body remains in the state of rest under the influence of the applied force, the body is in static equilibrium. So students, the last point is, how many force acts on that particular body? There are 4 type of forces acting on that particular bodies: applied force, normal reaction, weight, and frictional force. Weight and frictional force. But the net force is 0. What is net force? That is the sum of all the forces. That is, the normal reaction balances the mg, and the applied force is balanced by the frictional force. So this is in opposite direction, and this applied force acts opposite to the frictional force. So all the forces, vectorial sum of all the forces. Why you take vectorial sum, and we also tell in the next after classes, and so next classes. So applied and frictional force are oppositely directed, and the normal action as well as the weight, normal action and weight are in opposite direction. So vectorial sum of all the forces acting on that particular body is 0, that is the net force is 0, and the body remains in static equilibrium. So what is rest, and what is that is we can say that a particular body is in equilibrium when the net force is 0. But if the net force is 0 but the body is in moving, then we can say that this is in dynamic equilibrium. Then we can say that this is in dynamic equilibrium. So students, what is dynamic equilibrium? And students, and I want to tell you that this type of studying system, pen paper method, it is the best or not, and it is in your favor or not. Please tell me in the comment box. Okay. And so what is dynamic equilibrium? Let's take an example. Suppose, and this is a container, and it contains some liquid. Suppose this is castor oil or glycerin, something viscous, viscous liquid. What is viscous liquid? What is viscous liquid? And you can see that in the particular book when this is dynamic, a raindrop, this is the here is the point. A raindrop reaches the earth with a constant velocity, and the weight of the falling drop is balanced by the sum of buoyant force and the force due to friction or viscosity of the air. So what is viscosity, what is viscous? And this is just a little amount here. So viscous liquid means you have to think that it is more sticky than other liquid. Suppose you take two container, two bottle, and there is something honey and there is water, and you shake two bottles, and you feel which one of them is more sticky. That is obviously, students, this is honey. So honey is more viscous than oil. Okay. So there is a container and it contains a viscous liquid. It's something, it may be honey, it may be castor oil, it may be glycerin, and a spherical ball. A spherical ball, that is it ball bearing, in cycles ball bearing, with that we see that this type of ball. So it is a ball, a spherical ball is moving through that particular viscous fluid due to its, obviously, due to its weight. Yes, students, and due to its weight, so a number of force act on that particular. What are the different types of force acting? That is, first number is mg, and the second, we know that when a body is partially or fully immersed within a particular liquid, then buoyant force comes into play. And we observed it when this is a large container, or this is a large container. If we try to push this particular tin can, then a particular force in opposite direction acts, and this type of force is called buoyant force, and the tendency is called buoyancy. So this is a particular liquid fluid tendency. Fluid, it may be air, it may be water, it may be something liquid. So mg acts downward direction, and upward thrust is act. This is called buoyant force. Upward thrust, perpendicular thrust. Who gives this one? And that particular liquid gives on that particular body. And another force due to the viscosity, due to its sticky behavior. Suppose you think that something drags with a particular force due to the sticky nature of the fluid. So this is a type of force. This is called viscous force. So three types of forces acting on the body. There is upthrust. U means upthrust, and F equal to viscous force, and mg, this is weight. So what are the different type of force acting on that body? Upthrust, viscous force, and weight acting on that particular body. And the body is in equilibrium. So equilibrium means it is in rest. This is not correct. So equilibrium means the net force is zero. Net force. What is net force? There is the sum of the forces. Suppose upthrust is 2 Newton and this force is 2 Newton. So 2 plus 2, 4 Newton. The total force is 4 Newton, that is act in the upward direction. And when mg is 4 Newton, so the downward force is equal to the upward force. That is net force is 0. But the body is in that particular state. What is the state? This is in motion. So motion means the body moves along that direction, but the force is not acting. Force is not acting means force, that particular force acting on that particular body, but the net force is 0. The net force is 0. That is the vectorial sum. Vectorial sum means you have to consider the direction also. And if we add 2 plus 2, that is 4 plus 4, 8. This is not like that. This is in upward direction. So if you take this is positive, then the downward direction it is negative. So plus 4 and minus 4, this is equal to 0. So when the different forces acting on a particular body and the net force is 0, that is the vectorial sum. Vector means the physical quantity which possesses magnitude as well as direction. So vectorial sum is 0 means the body moving with a particular constant speed. Constant speed means there is no change in velocity. Constant speed or constant velocity somehow. Speed and velocity are same when speed possesses with a particular magnitude in a straight line. Suppose a body moves in a straight line, then its velocity and speed same. So difference is velocity is a vector quantity and the speed is a scalar quantity. And so students, constant velocity. So that particular body moves with a constant velocity means there is no change in velocity, there is acceleration equal to 0. That is acceleration. So what is acceleration? The change in velocity. But here in that particular case there is no change in velocity. So first of all students, you have to know what is rest, what is motion. There is the particular body is in rest, but that particular body is in motion. But the acceleration is 0 and the acceleration is 0. You can't move that particular body. So acceleration is 0 and you cannot change that state. That particular body is in a rest and that particular body is moving with a particular speed. So it's in motion. So you cannot change that motion. You cannot change that motion and the net force is 0 and the net force is 0. So this is a static equilibrium and this is in dynamic equilibrium. So what is a static equilibrium? So students, write down 3 definitions. Only 3 definitions. What is this? First of all, what is equilibrium? And the answer is, when pause the video and write down the notes now. What is an equilibrium of bodies? When a number of forces acting on a body produces no change in its state of rest or motion, the body is said to be in equilibrium. Yes. What are the different kinds of equilibrium? Static equilibrium and dynamic equilibrium. When a body remains in the state of rest under the influence of the applied forces, the body is in static equilibrium. For example, if a body lying in the table or if an almirah lying on that particular room and you applied a force and cannot move that particular almirah, then you can say that this is in static equilibrium. So next question is, what is dynamic equilibrium? When a body remains in the state of motion, it may be translational or rotational motion. Under the influence of applied forces, the body is said to be dynamic equilibrium. And the example is that a spherical ball is moving through a viscous fluid with a constant velocity. A spherical body, write down, when a spherical body moves through a viscous fluid with a constant velocity, with an acceleration, it is wrong, with a constant velocity, then we can say that the body is in dynamic equilibrium. So students, thank you, and next day we clear all the numericals. There is from 14 to 17. Okay, and for the next class it will be center of gravity. So the chapter is the uniform circular motion, and then chapter is finished, and then starts with work, energy and power, and before which we explain what is IIT foundation course, that is a greater or stronger depth is initiated for when the chapter is completed. So students, thank you, and if you think that the concept is really awesome, then please subscribe and share with your friends, and so that more and more students I reached in their hearts. Okay, so thank you, and wait for the next class.